I wanted to talk a little bit about some of the things that you really quite passionate to you do, and you've been spending a lot of time sort of researching and talking about as well.
Mm-hmm.
And the concept of the sort of, the software-defined everything, the software-defined data center. I've been looking at this market for many years now, as you have. You can probably tell we're similar vintage, maybe I'm a bit older than you. But, and we've been looking at sort of software-defined networking, software-defined storage, and all those sort of concepts. And we've been talking about software-defined data center, at least in my mind, for a long time. Mm-hmm. But you sort of said that you believe that 2020 is the year software-defined data center, if you like, comes of age.
Yeah.
And I'd love to get your thoughts on why. Why now? Why not in the last 10 years? What's changed this year or the last couple of years that are really bringing it to the fore today, do you think?
So software-defined data center was defined back in 2009, I think it was. Intel and a bunch of people were trying to figure out how to optimize inside of the data center. And it was defined as managing compute, storage, and network resources with independent management software systems. And the difference today is we are missing a dimension.
Okay.
So compute, storage, and network are software-defined, but facilities are not.
Okay, interesting.
So there's 4 elements there that have to be orchestrated. And so when you're able to now virtualize power, just like you virtualize compute and storage and the other aspects of it, you can now truly dynamically optimize the environments. Now, the difference today is that we've been optimizing the facility side with PUE. So that's the amount of power used by the facilities versus used on the compute for actual workload.
Yep.
And that's decreased rapidly over the last 10 years. And it literally has actually shrunk the slope on the actual curve of power consumption globally. But we've already picked that fruit. So now we've gotten to the point where data centers are very efficient as far as how they're designed and operated.
Okay.
The problem is that you have allocated capacity. So think of it as I'm going to do a 10 megawatt block of something. Then you've got buffers on that to ensure that you don't go above these breaker positions. So imagine another 20% on top of that. Then you've got redundant capacity. So when I have a failover, I need to have that capacity there. So in essence, you've got at least twice the amount of power that you actually use. Okay. That's for a 2N data center. Now, the majority of data centers are not that today. Mm-hmm. But what you also see is that the allocated capacity, imagine at 10 megawatts, they're using usually around 50 to 60% of the actual capacity consistently. That's it. So that means that I've got 50% of the actual contract capacity, 50 unused, plus the buffer, plus the actual failover. Mm-hmm. Now, all that capacity, does sound familiar? We did that in compute with dedicated equipment, with dedicated storage systems, with dedicated networks, and we realized that wasn't very efficient. Mm-hmm. So if we are able to now define the power as a pool and use that pool of software at the millisecond level of orchestration, we can have it operated just like another resource inside of a data center. Mm-hmm. The power will be virtualized just like compute, storage, and networking. Mm-hmm. So software-defined, critical nature of it is that you can orchestrate all of those elements at once. Mm-hmm. Now, you asked me about why this year.
Yeah, exactly.
There's an economic push. So the hyperscalers are the largest consumers of data center capacity around the world. They've built their own capacity for their own facilities. They've already done this optimization at various levels of maturity, meaning that they've got software orchestration and virtualization of power in their own facilities.
Okay.
But they also leverage all of the colos around the world. And when I say all, I mean all. Mm-hmm. They need capacity in all these different places for various levels of use. They can't get the same capability from the colos. So the colos are not software defined. They don't have an API that allows them to be able to control that at a millisecond level. Mm-hmm. And also the software, the data centers, the colos are actually defined by SLA. So they have a service level agreement that says, I'm going to make sure you have 10 megawatts of critical power all the time, right, for at least 6 nights. Mm-hmm. They're not going to compromise on that because there's penalties if they do.
Okay.
So there's fear in how it's going to be managed with software, just like we had fear with compute, storage, and network. Took a decade to get over that. But the economic pressure that's coming into the colos, their cost per kilowatt right now, expectations from their largest consumer, which are hyperscalers, needs to keep going down. They're reaching the diminishing returns on optimization, meaning that I've hit that floor on actual design that I can do without compromising resiliency. So then the only way to do this is to apply software to get smarter in how you actually deploy dynamically and manage the power itself, just like the other resources. Does that make sense?
Yeah, it does. So how do you think the colos particularly sort of handle their different customer types? So you've got the hyperscalers, pushing down demands on them.
Yep.
Then we have, in Australia, for example, organisations who are using co-location facilities don't really care much about power and cooling. They say, no, it's up to the colo, they can sort it out. We don't worry about it, kind of thing. Whereas we're seeing a much more focus on costs, on optimization. Yet customers are saying, no, we don't want to worry about it. We want something else to worry about it. So it's a kind of not really a disconnect, but if you like, how do we kind of get the two aligned more effectively together?
Well, it comes down to the consumer. So you take hyperscale, they are doing more than 50% of the actual contracts globally.
Yep.
Okay. Then you've got enterprise and retail. So wholesale and retail in the middle of this. Each of them have a various level of expectation and I guess care. Mm-hmm. So when I'm going into a retail, I just care about my costs and make sure this thing's going to be up. I use services handling it. Hyperscales have really, really figured out that, look, it's very simply, I want pass-through on energy, so no markup, and I want my cost per kilowatt, which is rent, right, of all the capacity that's deployed to be at this point. So the colos are at the point where half of their actual draw is going to be really low margins, which is happening already.
Yep.
Then it starts to trickle into the other ones. If they're able to orchestrate with software, they can unstrand power. So think about this, all this stranded power, if I could now take the capacity I've deployed, the capital I've invested, and be able to now take a piece of that and resell it, yet still maintain my SLAs, my margins go up.
Right.
And, there's a very simple economic thing in this one. They can't keep going down in the race to zero because they won't be able to justify actually serving the hyperscalers, which means the hyperscalers will continue to build out their own facilities. But the problem with the hyperscaler is they are still trying to do every country in the world. And deploying new regions and new zones and new capacity at edge, and they can't do it all by themselves. They just can't get to market that fast. They have to leverage all of these other players that have built up things, including Australia, right, that they can leverage. But they expect the same level of sophistication and capability in a colo that they do in their own. If not, right, they're not getting their metrics met.
Okay.
So if that is opened up at the actual colo, it breaks open that market to say they're giving the price points that hyperscalers would continue to invest more. Yet they're increasing their margins overall for all their customers. I mean, it's just economics at that point.
Exactly.
So to me, that's why this year is where software-defined power that enables software-defined data center will be a reality.
Okay. No, so that makes sense. And it's interesting, isn't it? 'Cause when we look at this, even though we have different concepts about software-defined power, we have hyperscale, we have cloud, all this sort of stuff. Essentially, a lot of companies are doing things, the way they've always done them, right? So to get to this software-defined level, clearly we need to make some changes in how we approach technology and so on. And that sort of brings in, the whole concept of edge, which when we look at edge computing, some pundits are saying it's going to be bigger than cloud, it's kind of going to take over the world, this sort of thing. So how do we manage this drive towards edge computing in a software-defined world? Are there different things we need to think about?
Sure.
Is it just a layer or component we orchestrate within that whole framework?
Yeah. Well, let's start at the macro level. So I believe that edge is going to surpass core eventually, right? It just comes down. Is it 5-10 years from now? I believe it is, because we have never had the amount of bandwidth, latency reduction, and concurrently connected devices that are going to be enabled by 5G.
Exactly.
So that's going to open the floodgates. And I've been talking about this data tsunami coming. So IDC predicted that we're going to have 175 zettabytes of data generated every year by 2025. Just put that in perspective, people are saying we got about 50 zettabytes today, right?
Big number.
Yeah. So we've got this massive 3.5 times increase in actual capacity that's going to be there. And I think that's actually low. So that means that people are going to start to consume more data, generate and consume more data, but they're also going to have an expectation of how the performance is done. So the concept here is when 5G opens up the capability, you're going to have gaming, medical, Internet of Things, smart cities, all of those truly relying on services in the place where people are, the concentrated places, these cities, which means that they're going to expect latencies that we don't deliver today. When you go back and open up your phone and do something, it goes back through a network and hits a core data center somewhere in a region that Google, Amazon, or somebody else is serving. But that's in the hundreds of milliseconds. When I'm now doing a full immersive experience with Oculus glasses or the next thing, I need to do 240 frames a second. And if I don't, my equilibrium gets thrown off when I throw up. So gaming is massive. That's going to be the leading edge of it. But so are all the orchestration of smart cities and autonomous vehicles and all those things that are going to require lower and lower latency. So for me, the demand is coming that we're going to have this capacity at closer and closer to the edge. Now, people have predicted that, cloud is going to eat the data center. Now they're saying that, the edge is going to eat the core.
Yeah.
The problem here is that people are looking at this as ethereal. It doesn't just go to the cloud. It goes to an infrastructure deployment somewhere. So we have capacity that continues to grow. Cloud, enterprise, on-prem, all those elements. We're going to have complementary capacity added at the edge. So to me, the issue is we got to prepare for a massive amount of data growth coming up here in the next 5 to 10 years. Massive amount of expansion in infrastructure because guess what? Consumers are going to demand it.
Yep.
We all are, right, completely addicted to our phones, and as experiences get better and better, there's going to be more and more requirement for higher and faster performance. So now, to go back to your original question, that starts to push things out to the edge. Now, how do we manage these multipliers of units all across the edge? You can't just take a data center that you have today and a rack deployment of a modular piece and just push it out to the edge.
No. Yep.
You have to rethink how it's going to be done. So will there be these modular ones at towers? Absolutely. Will there be ones that are going to be in server rooms and closets and in buildings? Absolutely. But you also have to think about these micro edge. The deployments are going to be all the way back at the last 1,000 feet. So you've got places like this or apartment buildings, etc. You're going to have lots and lots of needs. Now, that is a security vector issue. Like,
I was going to know what security. That's
okay.
Yeah.
But the how do you orchestrate that? We're going to have more devices, like by a factor of 100, out there in the world that are serving things that are security holes. But now you don't have the people to manage them like you do in highly concentrated data centers. So software defined on everything is going to be critical for every edge deployment. You have to assume it's lights out. You have to assume that capacity is going to be there and be managed, and you have to make sure that you're going to be able to scale up in those factors. Does that make sense?
Yep, absolutely. And then when you think about the, I guess the whole sort of customer or human experience that, the edge is going to drive and 5G is going to drive, all the devices and so on that we're using. Clearly, I mean, when you look at different geographies, even within countries, the access to certain infrastructure can vary dramatically. Here in Australia and in the States as well. I was in New Zealand, we were talking about 5G in Auckland on a roundtable I did last year, and one of the guys said, I haven't even got 4G yet, So how do we kind of balance that in terms of setting expectations, if you like, for the consumer, particularly when we can't necessarily guarantee they're going to get that same experience they expect everywhere? Do you have any thoughts on that? Because it's a tricky one.
It is. I do think that each city is going to be probably at a different pace. You think of the highly concentrated cities, the New Yorks, Sydney, those kind of things. They're going to have 5G faster because there's just a higher concentration of people and a higher demand. Now it's going to keep going out to the smaller cities and rural areas, etc. Over time. But in the next decade, the amount of actual capacity being deployed is going to be staggering. Because remember, we need 10 times the amount of towers to be able to serve this. Yet you're going to get 100 times more bandwidth. And then we're going to have this appetite by all of those users that is going to need to be satiated, right? They have to be able to serve it. So the demand will continue to go there. I think that I was just in India, right? And I'll give you an example. The entire data center portfolio for all of India is 400 megawatts total for all of India with 1.3 billion people. 7 million square feet. That's smaller than AT&T's portfolio.
It's pretty amazing, isn't it?
So, and they have an infrastructure challenge of, do they have fiber? Yes, a ton of it. Do they have power? Yes, challenged in different areas. But do they have the connectivity and the ability to manage it as they roll out? There's going to be a massive flood of it. It's going to be harder for them to scale up, but they will. And as will South Africa, all of LATAM. These emerging markets are going to grow pretty quickly.
And they have leapfrogged some of the mature markets as well, and some of the things they're doing in that. Yes.
And that goes back to software defined. If you think of, if they were able to adopt that at the beginning for both the core data centers and how they do it and how they attract hyperscalers, they could be getting contracts sooner than, say, a traditional market like the U.S. And also because of the saturation in the U.S. So that includes edge. As they deploy it, if they have software-defined mentality at the beginning, they'll have a competitive advantage, and they could accelerate.
Okay. So sort of leapfrogging some of the old mindsets that we've kind of embedded in lots of the other parts of the world.
Yeah, like China, right? They just basically jumped right ahead. Everything is paid through, WeChat and all the different applications they have. Yeah. They don't even worry about the other traditional credit card aspect.
Exactly. That's all gone. Yeah, all gone. Exactly. I'm interested also, we think about what organizations need to do, globally, but also in the local marketplace. And
Sure.
ADAPT has this framework, if you like, that we call the 12 core competencies for success.
Okay.
What business leaders, technology leaders need to be really skilled in and I guess able to actively sort of operate in those areas. And
Sure.
one of the things as we talk about these areas about software defined and edge and so on, emerging technologies, is how can we sort of enabling innovation and transformation, right? It's one of those sort of core competencies we believe that leaders of today really do need.
Yeah.
You're a leader. You've been doing this for some time. You've led organizations. I think the number has sort of been responsible for about $10 billion worth of technology investment. Big number by anyone's standard.
They're spending someone else's money.
Exactly. It's always good fun. So I'm interested from your point of view, what does innovation and transformation mean to you, not just as a concept, but, as a leader of technology, data center leader, cloud leader, or CIO?
Sure.
What do you think they need to be thinking about or looking at when they consider innovation and transformation?
I think as a leader, you really need to check yourself. It's very easy to follow the same patterns. Oh, this has worked for me before. I've hired these people. I've deployed this technology. I've followed this architecture. And just go do it again. It's a proven track record.
Yep.
What you probably should be thinking about, and where I think some of the best innovation that I've had in my career, is when I've stepped back and wiped the slate clean. And I've given my engineering teams and my leaders the challenge. I'd like you to go think about this. Could we do this differently? And you have the time and the space to do it. Giving them the capability to truly engineer and rethink is just amazing, the stuff that comes out of that. I mean, transformational type changes. We had the very first data center with primary power from fuel cells in Utah when I was working at eBay.
Okay.
Same concept.
Yeah.
Why? Because fuel cells were emerging and we keep doing the same things the same way for the last 2 decades. Can we actually generate power and consume it 100 feet away? Yes. And they did that. And it was just amazing what came out of it, and the probability factors and all the engineering, but it really made those people think. I think it's the same for software. It's the same for hardware. It's the same for network. You have to give your people the space to actually think differently than they do today. And it starts with you thinking differently.